Every electrical device we use comes with a price. We often find that our electrical bill tends to be higher during the summer months, when we're home more often and using things like computers, televisions, and air conditioners more often. You may ask, how is this measured? Well, similar to how water is paid for by gallon, electricity is measured through kilowatt hours. In short, 1 kilowatt hour is 1,000 watts per hour. This unit measures the power used by the consumer in a given time period, due to the fact that joules are too small to use. Recall that the formula for power is P equals delta E over delta T, where P is power in watts, delta E is difference in energy in joules, and delta T is difference in time in seconds. In order to calculate kilowatt hours, it is sometimes necessary to use this equation to find watts. Next, to calculate for kilowatt hours, the amount of power in watts is divided by 1,000 to find kilowatts, since there are 1,000 watts in 1 kilowatt. To find kilowatt hours, the amount in kilowatts is then multiplied by the time in hours, which sometimes needs to be converted from seconds or minutes. The government of Toronto has set rates by which a kilowatt is multiplied by to determine the cost. According to Toronto Hydro, there are 3 separate rates by which a kilowatt is charged. These rates are separated into periods of the day based on how much electricity is used on average at that time. Peak hours, which tend to be during the evening, are when prices are the highest, and low hours are generally in the early morning. Through this process, one can figure out the cost to operate an electrical device given the time, energy, and price per kilowatt hour. To further display how this is done, here are a few examples. Okay, in our first example, a household's television uses 10,500 watts for a total of 20 hours during the month. If the average rate is 10.7 cents per kilowatt hour, how much should this household pay for TV in their monthly bill? So we start with what we have. We know that we have power, and that would be 10,500 watts. To convert that into kilowatts, of course, we need to divide it by 1,000. So we're going to go 1 kilowatt over 1,000 watts. And then do the calculation. We'll get 10.5 kilowatts. Next, we know that we have time, which is 20 hours. This we do not need to convert given this information. And then we have cost. Cost is equal to 10.7 cents per kilowatt hour. Okay. Now we have our formula, which is P equals delta E over delta T. Since we have P and we have delta T, we need to find delta E. So we rearrange the formula and we would say delta E equals P times delta T, which equals 10.5 kilowatts times 20 hours, which equals 210 kilowatt hours. And now go to our second part, where we see that it's 10.7 cents per kilowatt hour. So we go to 110 kilowatt hours and multiply by the rate. Which gets you 2,247 cents. Which divided by 100 would get you the amount in dollars. So it's going to be $22.47. And now we can go back and look at significant digits. You see if this one has 1, this one has 3. But considering this is a dollar amount, we can keep it that way. So, therefore, this household paid $22.47 for television. That month. Sometimes when either power or time is not given, we have to use the same formula twice. So in this question, the speaker system uses up 364,000 joules in one day for an average of 250 watts. If the speaker system was used during the peak hours of the day, and Toronto Hydro charges 11.8 cents per kilowatt during these times, how much did it cost to operate the speakers that day? Once again, we go with what you know. We have delta E, which is 364,000 joules. We have power, which is 250 watts. And we have our rate, once again, which is 11.8 cents per kilowatt hour. So in this case, we look back at our formula. V equals delta E over delta T. And we have delta E, we have P, so we're looking to find delta T. So rearrange the formula, delta E over P equals delta T. Delta T equals delta E over P. In this case, it equals 364,000 joules over 250 watts, which equals 1,456 seconds. Of course, we get it in seconds. So in this case, we need to convert seconds to hours if we're going to use the formula a second time. So 1,456 seconds over 1 times 1 minute, which has 60 seconds, so you divide by 60, and then 1 hour, 60 minutes. Cross out the units. So this is divided by 60 twice, which gets you 0.4044 hours. Convert watts to kilowatts. Once again, dividing by 1,000. Which equals 0.250 kilowatts. Once again, this time, go back to our formula, equals delta E over delta T. This time we have P and we have delta T, but we need to find delta E once again. So you rearrange it and you say that delta E equals P times delta T, which equals 0.250 watts times 0.4044 hours, which equals 0.1011. Kilowatt hours. Again, significant digits. This one has 3, this one has 4, so we need to round it to 3. 0.101 kilowatt hours multiplied by that rate, which we cannot consider significant digits in again because it's a dollar amount, which has to be expressed in 2 decimal places. So 11.8 cents per kilowatt hour. equals $1.19 divided by 100 is $0 and 1 cent rounded. Anyways, therefore, it cost 1 cent to operate the speakers that day. And there we are. And really, cost of energy is an important real-world application of the P equals delta E over delta T equation that affects us all the time. I hope this video has given you insight into how your electric bill is calculated and how all of these variables work in relation to each other.